Well, we just started a new unit, but I'll look up some problems that I believe are on the website.
Okay. Have you gotten to quadratics yet?
No.
Okay. So you're still on linear functions.
Oh no, we're past that.
Okay.
Yeah. We took a test like 2 days ago.
Okay. How'd you do?
I did pretty well.
Good. Glad to hear that.
Yeah. Sorry, the internet is really slow in my room.
It's okay.
It's taking a while to pull up.
Now, are these problems that you have to answer online also? Is this like Math Excel?
No.
Okay, so this is just a source that's giving you your homework problems?
Yes.
Okay. Because I was going to say, I can always bring it up on my end if it's faster. In other words,
Yeah.
part of the reason it's slow is because you're running GoToMeeting in addition to trying to access this site.
Oh no, I'm doing this on my phone.
Oh, really?
Yeah.
Oh, you're accessing the homework on your phone, not your
Yeah.
computer? Okay.
Yeah. It's almost done loading.
You have an iPhone or a Samsung?
iPhone.
Okay. Come all my students have iPhones. I'll bet you 95% of my students have iPhones.
What is the date today?
Today is the 16th, November 16th.
Okay. Alright, so I have it here.
Okay.
So we're simplifying radicals and solving by square roots.
Okay.
Alright, so the first one is we have to simplify the expression square root of 48.
All right. The thing to know about radicals is if I have the square root of the product of two numbers, I can always separate it out into that. Okay?
Yeah.
Same thing if I'm dividing A over B. That's going to be the square root of A over the square root of B. So the secret to simplifying this is to find factors of 48, one of which is a perfect square number. What are your perfect square numbers? 4, 9, 16, 25, 36, 49, and so forth. So I'm looking for a factor of 48 that's one of these numbers. If it's not one of these numbers, it doesn't do me any good to factor it.
4 is
Okay, I could do 4. What's the other one?
12.
Okay. Now that can be written as 2 root 12, but root 12 isn't simplified. What does root 12 equal to?
6 and 2.
Well, neither of those is a perfect square number.
4 and 3.
4 again. So that becomes 2 root 3. So now I have 2 times 2 root 3, which is 4 root 3. That's the
I see. Alright.
See how I got to that?
Yeah.
Now, notice that had you noticed that 16 is also a factor of 48,
Yes.
then it would be square root of 48 equals square root of 16 times square root of 3. Immediately, I get to the answer in one step or 2 steps,
Yeah.
as opposed to the 2 or 3 steps that it took me doing it the other way. So there's always an advantage if you can find the maximum perfect square number as one of your factors.
Alright.
Okay? In other words, if I took the number well, I could break that down into a lot of things. I could break it down into 25 times 8, but I could also break it down into 100 times 2. Which one is going to be more effective?
25 and 8.
No? This one immediately gets you, the square root of 100 is 10, so I immediately get to that answer. This answer gives me 5 root 8, but notice root 8 is not simplified. Root 8 is equal to root 4 times root 2, so that would turn into 2 root 2, and this would eventually turn into 2 or 10 root 2. So I get the same answer in either case, but I get it a little quicker if I recognize that 100 is the maximum factor that is a perfect square number.
Oh, okay.
That's always the key. You're looking for perfect square numbers. Let's talk about that a little bit more. Does this simplify?
Yes.
No. It certainly factors,
Doesn't simplify.
but neither of those numbers is a perfect square number, so I can't do anything with it. In other words, it only simplifies if you can pull a whole number out of it. Root 8 simplified because that was root 4 times root 2, which was 2 root 2. In other words, I was able to pull that 2 out.
Mm-hmm.
In the case of root 10, that's simplified. You never simplify that into root 5 times root 2. You only simplify it if you can pull a whole number out.
Alright.
What other problems do you have?
The square root, no, the negative square root of 125.
How much?
125.
Okay. Well, think of factors of 125. Are there any factors that are perfect square numbers?
No.
$1.25 is 5 quarters.
Yeah.
So it's 25 times 5, right?
Oh yeah, but that's not a perfect.
25 is a perfect square number.
Really?
Yeah, the square root of 25 is 5.
Oh, okay.
5 times 5 is 25. So that gives me minus 5 root 5. And that's my answer. Whoops. I meant to circle the whole thing. Definitely got to carry forth the negative sign.
Mm-hmm.
What's this?
Square root, that is negative 2.
There is no number. There is no number that when you multiply it by itself that it equals any negative number. So this doesn't exist except in the
it's a
when you bring
imaginary,
in
right?
imaginary numbers it does, but you haven't gotten to imaginary numbers yet.
I did that last year though.
Really? They got to imaginary numbers. Okay. Before you reach imaginary numbers, you're only allowed to take square roots of positive numbers only.
Yeah, we did I went to an AP school last year.
I was going to say, that's pretty unusual that you would get imaginary numbers before Algebra 1. Most of my students don't get imaginary numbers until Algebra 2 and late in Algebra 2. I don't think your sister has gotten to imaginary numbers yet.
Yeah, we did it a little bit last year.
Yeah, they're an interesting breed, as you might suspect, by the fact that they're called imaginary. You know, is that like an imaginary friend? Kinda. They're not real, but they're useful when you're doing higher mathematics. All right, what else do you...
I told, back when I went to that school, I made a joke in front of my math teacher. but it was very funny.
What
Now
was
he
that?
told me he's going to tell it to every single
Huh.
person. But, like, doesn't even know any imaginary numbers. And I said 11.
Oh, 11. Yeah. Well, imaginary numbers are always something that's puzzled me. I've always wondered exactly why they're useful in mathematics. And they're
Yeah.
useful in electricity, for sure. They're used in electricity. But in terms of other mathematics, they're extremely useful when you study much higher mathematics, like calculus and beyond. Um, and it's just kind of like a useful tool. It's not a real number, but it's a useful tool. In a way, it's like a negative number. I mean, what the heck is a negative number? You can't have a dimension that's negative. You can't have time that's negative. So a negative number is like a tool also.
Yeah.
All right, what else do you got?
We got half square root of 112.
So 112 have a factor that is a perfect square.
Um, I believe not. I
Let's
may be
talk
wrong.
about let's talk about numbers that are divisible by 4.
Yeah.
For a number to be divisible by 4, the only thing that has to be true is that its last 2 digits have to be divisible by 4.
Oh, so
This number that
the
I wrote right there is divisible by 4, and so is this, because 12 is divisible by 4. So let's
oh no,
divide
it'd be
by 4 and see what we get.
28, 28, right?
Yep.
Yeah.
Hold on, I wrote it wrong. I always like to write the 4 first because that's what's going
Mhm.
to allow me to pull a number out. I can't do much with 28, although we're going to look at 28 in a moment. I actually can divide 28 by 4. What does that tell me? The fact that 28 also has 4 as a factor, what factor of 112 would have been better to use than 4?
Um,
16. 4 times 4.
yeah.
In other words,
Yeah.
here's why. Here's why. If I want, I can write this thing as the square root of 4 times the square root of 4 times the square root of 7.
Okay.
And that I could have written all along as the square root of 16 times the square root of 7. Notice that 16 times 7 is 112. And now that becomes 1/2 of 4 square root of 7. And now the 4 and the 1/2 become a 2. So that's my answer. And again, I can get to it in a number of ways. There's nothing wrong with dividing by 4 to start.
Okay.
Because a lot of times it's tough to figure out that 16 is a factor. I didn't even recognize that. I did not recognize that 16 was a factor of 112. But once I broke it into 4 and 28, I know that 4 is a factor of 28, which means since
Yeah.
there's multiple 4 factors, I should have factored out 16 in the begin with.
Mhm.
But it doesn't matter. There's nothing wrong with doing it where it takes an extra step to do it. And that frequently is the case when 16 is one of the factors because very few people recognize the factor 16. So there's nothing wrong with doing it this way and then turning that to that. And then you can take square root of 4 times square root of 4 and just make that equal to 4 if you want. Now,
Okay.
square root of any number times the square root of the same number is always that number. Square root of 19 times the square root of 19 is 19.
Yes.
All right. What else you got?
Let's see, we have square root of 7 times the square root of 8.
Times square root of 8?
Yep.
Okay. This is kind of the reverse. Remember that I said the square root of a times b equals the square root of a times the square root of b?
Yeah.
Well, that works from right to left as well as from left to right.
Okay.
This time we've got this part.
Yeah.
So what's that equal to?
Um, would it be, hold up.
Well, it's square root of a times b. Square root of 56.
Oh, yeah.
In other words, that's a true statement. It's still not simplified.
Mm-hmm.
And let's back up a step. Instead of strictly multiplying 7 times 8, let's simplify what we have here. Well, I know that square root of 8 is always 2 square root of 2, because I can pull a 4 out, right?
Yeah.
Well, now when I multiply those two together, what do I get?
You get 14 square root of, oh wait, no, yeah, you get square root of 14 times square root of 2.
Just times 2. In other
Oh,
words,
yeah.
it's that. And
Oh, yeah.
general
Square.
practice where you put the whole number in front, not afterwards. The problem is
Okay.
if I write it like this, nobody knows whether that 2 goes under the radical sign or not.
Yeah.
So if there's a whole number involved, you usually put it in front. But is all I'm doing when I multiply these two together is multiplying 7 times 2 inside the radical sign, which gives me radical 14, and then this 2 goes along for the ride.
Okay.
Okay? So even though square root of 56 is correct, well, that's square root of 4 times square root of 14, which is 2 root 14. But the problem is easier if you simplify that first rather than waiting till you get to there to simplify it. It's always going to be simpler to simplify smaller numbers. It's easier to simplify root 8 than it is root 56. You agree?
Yes.
Yeah, I mean all I have to do is figure out that 8 is 4 times 2. 56, I got to figure out that's 4 times 14. That's much harder. So whenever you
Yeah.
have a problem like this, always simplify immediately if you can. And remember, it's only simplification if I can pull out a whole number. I pulled out a 2.
Okay.
Okay, what else you got?
Let's see. I have 2 times the root of 5 fourths.
I didn't catch the rest of that.
2 square root of 5 fourths.
5 fourths.
Yes.
Okay. That it?
Yes.
Okay. Well, let's talk about square root of 5 fourths.
Okay.
That's the square root of 5 over the square root of 4.
Yes.
Or just like multiplication, we can take division and separate it into 2 separate radicals. Well, notice that's the square root of 5 over 2. That's fully simplified.
Okay.
Okay? So if I turn this square root of 5 over 4 into square root of 5 over 2, then I have the following. Now the 2's cancel, and my answer is square root of 5.
Okay.
Let's talk about that for a moment.
Okay.
What's that equal to?
Square root of 1/2 is equal to.
Break it up into 2 things.
Okay. So it's the square root of 0.5, right?
No, leave it as a fraction.
Okay.
It's the square root of 1 divided by the what?
The square root of 2.
Okay. Which is 1 over square root of 2, because the square root of 1 is 1.
Yeah.
But there's a problem with that answer. It
Okay.
has an irrational denominator. And math does not like irrational denominators. You know what I mean by irrational?
Mm-hmm.
I cannot write square root of 2 as a fraction. I
Yeah.
can approximate it as a decimal. Square root of 2 is approximately equal to 1.41, but it's kind of like pi, and then it goes on forever and never repeats. So if I want to write this the most accurate way possible, I write it like that.
Mm-hmm.
But you can't have it as a denominator. So we have to do a process called rationalizing the denominator. And what I do is I multiply the top by square root of 2 and the bottom by square root of 2, which is the number 1. I can multiply any fraction by the number 1 without changing its value.
Mm-hmm.
And what I get is square root of 2 over 2. And that's the proper answer.
Okay.
Because I don't care if I have an irrational number in my numerator. I just can't have an irrational number in my denominator. Okay? So 1 over square root of 2 is the same number if you were to put it into a calculator as you'd get if you put in square root of 2 over 2. Those
Okay.
are identical. It's just that this is considered proper math notation. This is considered improper.
Okay.
And it's not totally clear when you look at the square root of 1/2 that you're looking at that. It's only when you separate it into a numerator and a denominator that it becomes clear that you have an irrational denominator. Have you been taught that yet, how to rationalize a denominator?
No.
All right, you will, almost certainly this year.
Okay.
All right, what else you got?
Let
Especially
me
now
see.
that you're talking radicals.
Yeah, I have the square root of 32 times the square root of 8
Times what?
times the square root of 8.
Now, we could just multiply that, and
Yeah.
that's equal to 236.
Yeah.
But then I'd be faced with having to simplify that big number. I have no idea what factors of 236 are.
Okay.
So let's break this down. Let's simplify each of these radicals before we multiply it. Well, what's the
Okay.
largest factor that's a perfect square number of 32?
The largest?
Yeah, the largest. Remember, that's the way we get to the answer the quickest.
It's 16.
Ah, good. 16 times 2. How about 8?
Um, yeah, 8 and 2.
That's 4 times square root of 2.
Yeah.
Okay. Now, let's take the 16, turn it into a 4. So I have 4 square roots of 2. Let's take the square root of 4, turn it into a 2. You seeing everything I'm doing here?
Yeah.
Okay. Well, now I can multiply the 4 times the 2. Remember what I'm doing here is I'm multiplying 4 times square root of 2 times 2 times square root of 2.
Okay.
Multiplying those 4 numbers together. Well, if I multiply the rational numbers, I get 8. What's square root of 2 times square root of 2?
That is a square root of 4.
Which is?
This
2.
wait. Yeah.
So the square root of 2 times the square root of 2 is 2. So when I multiply those two together, I get another 2, and the answer to that is 16. know it's wrong. I didn't do my multiplication correctly in the first place. That's not 236. 8 times 3 is 240, and if I add 16 to that, it's 256. That's right.
Yeah.
Well, 16, the number we got by doing it this way, is the square root of 256. But
Okay.
you might not have seen it. In other words, if I give you this problem and I say you cannot use a calculator, you're going to have a hard time solving it from that. I don't know who knows how to take the square root of 256 if you don't happen to know what it is. But if you do it this way over here, then you end up with something relatively simple. You end up with 4 root 2 times 2 root 2. You multiply the whole numbers together, multiply the radicals together, and you get 16. So it's always best to reduce and simplify first before multiplying. It's a little bit like the following. Excuse me. Now, there's 2 ways you could do this problem. You could multiply 7 times 5 times 8 and get a numerator. Then you can multiply 4 times 7 times 5 and get a denominator, and then go from there with your calculator, right? You need a calculator at that point because you're dealing with 3-digit numbers. But what if I simplify first? That 7 cancels with that 7. That 5 cancels with that 5. Now I got 8 over 4. That answers 2. I don't need a calculator to do it if I simplify it first.
Okay.
So whenever you have problems like that, reduce first. Always try to figure out what will divide into the top and bottom evenly.
Okay.
All right. Probably a good place to stop, Nick. Are you guys off? You're in Jefferson County School. You're at Ralston Valley, aren't you?
Yeah.
Are you guys off all next week?
I believe so.
Okay, what are the implications going to be for the tutor?